Meet Gloria. She is a giraffe that lives at a local rescue and conservation park. Gloria's neck was recently measured to be 180 centimeters in length to the nearest 10 centimeters. Let's use this measurement to learn about bounds. So first, what are bounds? Well, we have an upper bound, and this is the largest number our number could have been before it was rounded. So we say that anything less than this number could have been our number. And then we have a lower bound, and this is the smallest number our original measurement could have been. Otherwise, it would have rounded to a different number. So we state that this number, or anything greater than it, is our lower bound. Given 180 centimeters, what could our bounds have been? So if we find our upper bound first, our number could have been 181, 182, 183, or 184, and these would have all rounded down to 180 centimeters because we rounded to the nearest 10 centimeters. But if it was 185, this would have rounded up to 190 centimeters. So that's our upper bound. So we say that it must be anything less than 185 centimeters. Now looking the other way to find our lower bound, her neck could have been any number from 175 centimeters all the way up to 180 centimeters, and it would have rounded to 180. Lower than 175 would otherwise have just rounded down. And we express this in an interval like this, and by positioning length in the middle of this interval, we can simultaneously say that our number is greater than or equal to one number, whilst also being less than another. Gloria weighs 123.1 kilos to the nearest 0.1 kilos. In a similar pattern to our last measurement, we know that any number between 1123.10 and 1123.14 would have rounded down to our 123.1 kilos. So we know our upper bound is anything less than 1123.15. So to find our lower bound, we need to find the number that is the lowest that would have rounded up to our target number. In this case, it's going to be 1123.05, as anything greater than or equal to this number would have rounded up to our target number. This radioactive meteorite is 4.2 billion years old to the nearest one decimal place. Let's find the bounds of this. So any number lower than 4.25 is going to round down to 4.2, so this is going to be our upper bound. And now finding our lower bound, anything equal to or larger than 4.15 is going to round up. So our interval sees our bounds as 4.15 and 4.25. Our meteorite contaminated the soil that it landed on. A sample of soil from the crash site was taken and its radioactivity was measured. This was the measurement that was found, and it was rounded to 3 decimal places. Finding our lower bound first, if our radioactivity was measured to be lower than 1478.3115, then when it was rounded to 3 decimal places, it would have instead rounded down to 1478.311. So this is going to be our lower bound, as it's the smallest number that rounds to our value. Same idea with our upper bound. If our measurement was 1478.3125 or higher, then it would have rounded up. So we know that anything less than this value is our upper bound. Moving on to 2 final short examples. This is a skid steer loader. It has a hydraulic pressure system to power the lift arms and bucket. The maximum weight it can lift was measured to be 2,000 pounds to the nearest 100 pounds. This means we will find our bounds that would have made this measurement round to either 100 lower or higher, so 1900 or 2100. And we find this at our midpoint between these numbers, so halfway in between. Is exactly the same as what we've been doing before. I'm just explaining it in a slightly different way for clarity. So we can say that our lower bound would have been greater than or equal to 1,950 pounds, because anything lower would have rounded to 1,900. And our upper bound is less than £2,050, as anything higher would have rounded to £2,100. Our final example is an American chestnut. In the 1950s, their species was plagued with a fungal infection called blight, and their population was decimated. To try and reintroduce them, blight-resistant chestnuts have been developed, and at a conservation site in Colorado last year, 2,700 trees were planted, but this number was rounded to two significant figures, the 2 and the 7 here. So our bounds are going to be the numbers that would have caused our number of trees to have been rounded to 2,600 or 2,800. Well, 2,750 would have rounded up to 800, so we know that that's our upper bound. And similarly, any number lower than 2,650 would have rounded to 2,600, so this is our lower bound. If you need a reminder on significant figures, please see the video on that too. The last thing I want to do in this video is introduce you to questions that look a lot harder, but really just require a small amount of extra work. The plot of land that these trees were planted on was 250 meters wide and 400 meters long. These were both measured to the nearest meter. Find the upper and lower bounds of this plot of land's area. So for questions like this, we start by finding the bounds of our measurements with the same technique we've been using. Let's do the width first. The bounds of our width are going to be 249.5 meters for our lower bound and 250.5 meters for our upper bound, because we said that our measurements were rounded to the nearest meter. For length, 399.5 meters is our lower bound and 400.5 meters is our upper bound. And now we can use these to find the bounds of our area. So the area's lower bound is found by multiplying our lower bounds together. And then all we have to remember as well is that it will be meters squared because it's area. And then we do the same to find our upper bound, multiplying our upper bounds together.